Hello everyone, I'm going to be finding for the exact length of the polar curve r is equal to theta squared. First, of course, we want to know how this polar curve looks like, right? Okay, so first, I'm just going to plot a few points and let's see how it kind of looks like. So when theta is pi over 2 is like approximately 3 over 2, and if we square this, we have 9 over 4. Just say that that's like 2. Let's just say that this is like approximately 2. And when theta is 0, of course r is 0. And as theta gets larger and approaches pi over 2, the radius will also get larger and approach 2. So it'll connect kind of like this. And then when theta is equal to pi, we have like approximately 3 to the power of 2, which is like 9. So let's just say that this is approximately 10. Then we can say that 10 is like about here. And also as theta gets larger and approaches pi, the radius will also become larger and approach 10. So it'll like connect like this. And then when theta is equal to 3 pi over 2, we square that. And let's say that this is like approximately 10 over 2, which is like 5. So let's just say that this is 25, approximately. Then that will be like all the way down here, right? Like way down. Let's just say that 25 is over here. And then as you can see, as theta gets larger, the radius will also get larger. So if we actually draw this whole thing, it'll look something like this. And then like it goes on forever. And this is when it's 2 pi. So theta is equal to 2 pi. And also, well, I'm so sorry I didn't mention this, but we want to find the exact length of the polar curve of r is equal to theta squared when theta is between 0 and 2 pi. So don't forget this. And so yeah, so the polar curve will just be just this length. It stops right here. And now how do we find for the exact length in a polar curves? Well, let's say that we have like a polar, let's say that this is a polar curve, and we were trying to find the exact length of this polar curve. Then what we would do is first, we'll find like a very small portion of this curve. Like that's a straight line. And then then we have this. So this angle is d theta, and then we have this length as r, of course, right? Wait, I don't know if I drew this perfectly. Well, I'm going to change it up a little bit so that you guys can see more about what I'm talking about. Alright, I think that's a little bit better. And also, we're going to call this length ds. Okay, and now we have this, we're going to have like this small triangle is a right triangle. So this angle is a right angle. This length will represent the r. And since this length is r, and this length is also r, that will make this whole length r r plus dr. And so that would make this dotted line, the length of this dotted line, as r multiplied by dr. So it's just the radius multiplied by the angle, right? And now, using Pythagorean theorem, we can solve for the length of the ds. I know that there wasn't really any point of pointing out that this whole length was r plus dr, but I was just saying. And so the length of ds by Pythagorean theorem would be the square root of dr squared plus r multiplied by d theta, all of this squared. And then we're going to multiply and divide d theta on here. And that would give us the square root of dr divided by d theta. Oh, I'm running out of ink. Then I'll have plus r multiplied by d theta divided by d theta, all of this squared. And then of course we have this whole thing multiplied by d theta, since we also divided by d theta. And that would cancel things out. Okay, now I'm going to use this formula to find the exact length of this polar curve. This would be just the length of a very small portion. So like, for example, this length could represent like a very small portion of this whole length of this polar curve. So like it could represent this small section. So like this length would be a ds, right? And we have like infinitely amount of them, and we're going to add those up. And that's what the integral sign is for. The integral, we're trying to find the exact length from when theta is between 0 and 2 pi, so that would be our interval. And then we have this formula. We have the square root, and well, of course, these two cancels out. So we'll have the square root of dr divided by d theta squared plus just r theta, r squared, and multiplied by d theta. And now I can just put all of the information that we know in. So this is equal to the integral from 0 to 2 pi. I'm gonna have to start small, writing smaller. So the square root of dr divided by d theta, which would be taking the derivative of this. So, wow, I really don't have any room. Okay, you know what? I'll write it up here. Dr divided by d theta would be equal to what we take the derivative of this, which would be 2 times theta. And so we're going to replace dr divided by d theta with 2 theta, which would give us 4 times theta squared if we square the 2 theta. And then we add r squared, and r squared would be equal to theta to the power 4. And then we can just integral this, right? We can integral this by hand. But I don't think I have room, so I'm going to erase some parts. We have the integral from 0 to 2 pi of the square root of 4 times theta squared plus theta to the power 4 d theta. Now we can factor this out a little bit. So the inside of the square root we can factor out with theta squared. So theta squared plus theta squared multiplied by 4 plus theta squared. And the theta squared can come out of the square root and make a theta multiplied by the... We still have the square root of 4 plus theta squared, of course. And then how do we integral this? Well, we of course use E substitution rule. Let's set u is equal to 4 plus theta squared. That would give us the du as 2 theta d theta, we divided 2 on both sides since we only have d and d theta. So we're going to replace d and d theta with 1/2 multiplied by du. The 1/2 can go in the front since it's a constant. Multiply that by the integral of, we'll also have new intervals, right? So if we put in the 0 for theta here, we would have u is equal to 4. If we put in theta is equal to 2 pi here, we would have 4 plus 4 times pi to the power of 2. Then we have just the square root of u left. Now, I have no idea why I just suddenly switched over to this color. I was only going to do it for the substitution part. And then we have 1/2 multiplied by 2 over 3, so that's 1 over 3, multiplied by u to the power of 3 over 2. It's like, I got 1 over 3 by multiplying 1 over 2 with 2 over 3. And then we put in 4 and 4 plus 4 pi squared. Let's put in 4 plus 4. Let's put in 4 plus 4 pi squared first, and we have 1 over 3. I'm going to take out the 1 over 3. We'll have 1 over 3 multiplied by 4 plus 4 pi squared to the power of 3 over 2 minus 4 to the power of 4 to the power of 1/2 is 2 to the, and 2 to the power of 3 is 8. So this is what we'll have. And then of course, if we wanted this in decimals, we could approximate this with our calculators. Okay, let me just calculate this really quick. 1 divided by 3, all multiplied by 4 plus 4 pi squared to the power of 1.5 subtracted by 8. Okay, so I think I did everything correctly. Focus camera. Okay, there you go. And then we get 82 point. Okay, if I round this, I'll get 82.9. And so that would be our answer, 82.9. Thank you for watching, everyone. In this video, I solved for the exact length of this polar curve, r is equal to theta squared, and we got 92.9. I also showed you guys how to find for the formula of finding the length of polar curve, and I actually just learned that. And I'm so sorry I forgot to add this, so I'll just put that in caption in the beginning of the video. Thanks for watching, everyone. Bye.